Hi guys, and welcome to the next video. First of all, thank you so much for 1,000 subscribers. I'm very happy and I wish to continue. So guys, don't forget to subscribe, hit the like button so I know I can continue doing what I'm doing right now. And 1,000 subscriptions, I was thinking about it. I think it's time to do something special. So today we're going to talk about FANUC variables. Let's get started.
5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Alright, we're going to talk a little bit about FANUC variables today. Of course, we're not going to cover all of them because there is like thousands of them, so it's not going to be easy to cover. However, I wanted to share with you the one that I find the most important and the most helpful in the programming, and the one that probably you would like to change to your own preference so we can make the programming easier. As a bonus for you guys, in the description down below, I'm going to make a link to a PDF that I created that you can download from my website, where you can find all of them listed with a short description. So you can have it on your phone with you all the time, and hopefully that's going to help you program faster and easier. Alright, so what are the variables in general? Variables store some kind of an information, and they can be changed. And they can store many things, from strings to Boolean values, so 1 or 0, to integer values or real values. And there are, like I said, thousands of them in FANUC Robot. Some of them you even cannot see because they are hidden by FANUC, because for your safety, so you cannot access them. Some of them are accessible. Some of them are read-only. Some of them you can change. Today we're going to talk only about the one that you can actually change, and the one that are going to make your programming easier and faster. The one that I'm using personally often, because sometimes it annoys me that some settings are not the way I want them. So I'm going to share that with you. Let me just make a brief introduction to what I'm going to say. So first of all, I'm going to talk about the variables that store the master counts. That's for robot mastering, and that I already mentioned in my mastering video. If you haven't seen it, check it out. I will link it up the top. What else? There are the most things that are important for me. The most important things are the speed override. So when I'm programming, I like to change the speed with the plus or minus keys in the way I like. So there are two options in FANUC. One is you can change with using the shift button, and the other one is without using the shift button. If you use the shift button, you're going to jump by default from 5 to 10, 25, 50, 75 and 100. And I'm sorry, from 50 to 100. And that's something that annoys me personally, because I really like jogging and changing the speed while the robot is moving, so I can slow it down and speed it up. However, jumping from 50 to 100 by just one click, that's something that really basically is not the way I want it. So I'm usually changing this variable to either disable the shift override, so even if you hold the shift or you don't hold the shift, the robot will still act the same, or I'm changing the increments on the shift, so the robot is going to act as I want, and I want to show it with you while I will do the exercises. What else? There is a very nice variable that I found, and I think it's very useful. Of course, it depends what application you're working on. Since I work with many different applications, some of them like spot welding or stud welding, or maybe gluing application, they require a certain distance from the part where you should teach the robot point. So there is a variable that's going to allow you to move a certain amount of millimeters when you hit the jog button. So I don't know if you work with KUKA, but in KUKA robots there is also an option of setting a value in millimeters or inches. where you will say, hey, when I hold this button, please move for 1 millimeter or 5 millimeters or 10 millimeters and then stop. So I'm going to show you the variable in FANUC where you can change it, and it's very cool because often I needed to hold a distance of, let's say, 3 millimeters from the part to the glue nozzle, and it was very annoying to doing with the ruler. So I found the variable, and basically you will just jog the robot to the point, hit the, for example, Z button to go minus from the part, and it will move by a fixed distance that you will define in a variable. Very, very useful from my point of view. So we're going to go through all of that in the exercises and maybe a little bit more. And I think you will like the video. And after that, the next videos that are coming are going to continue the latest topic that I've talked about, which is the robot logic. So we're going to cover if statements, jump labels, and so on and so on. But today, variables. Let's do it. Okay guys, and welcome to the next video. Today we're going to talk about FANUC variables. So first of all, how do we get to the variables? So we're going to do that by hitting the menu button. Then we're going to go to next. Then we're going to go to system, and we're going to select variables. So in here there are thousands of variables that you can access because it's a lot of them in here, and as you can see they are sorted alphabetically, so they go from A all the way to Z. And why I'm saying there are thousands of them, because when you access a variable there is more variables inside the variable. So those are just group of variables. Not all of them, some of them are just single variables like those, but in most cases you will have access to more than just one variable inside a variable. But let's talk about the variables that we are interested in. So the first one I wanted to talk about is a DMR group, and that stands for Dynamic Mastering Record. So let's get there. As I said, everything is alphabetically, so you just scroll down until you find your variable. Okay, so we have it in here. In my case, it's variable 203. However, on your robot, that might be on a different number. So we want to hit enter right now. So you will get inside the variable. You can hit either enter or detail, that will do the same thing. Okay, and in here, as you can see, there's like a set of variables, and I wanted to stop in here for a while. Why? Because there are many variables in here that you are probably interested in. One of those variables is the variable master done, and I'm talking a little bit about it in my mastering video. So if you haven't seen it, check it out. So basically that variable tells us whether or not the robot has been mastered. And what else? We have as well the master count in here. So as you can see in here, that's master count variable. And when you enter that variable, you can see all of the master counts that are saved on the robot. So those should match whatever you have on your FANUC sheet that came with the robot, and that's where the value is stored. Again, I talk about it more in my mastering video. When you go back, there are a few more things that you want to know. So again, mastering video and the reference position. So when you go inside this one, you can see at what angles the robot has been mastered. So if the reference position has been saved on a different angles than 0, 0, 0, those will show up here. And the last variable I wanted to talk about in here is basically the reference count. And in here you can see the encoder pulses at the reference position. Okay, so that's it about the DMR group. I'm talking about it because often when I get a new robot or when I get to a new site, I will check if the master counts match, and I want to make sure that the robot is mastered correctly before I start my work. Alright, that will be it from the DMR group. So let's jump to the next group, which is the jog group. So basically this is a jog system variables. So again, everything is alphabetically. Just scroll down until you get to your jog group. In my case, it's 359. So you want to go in and one more time, and in here the fun starts. So I believe the jog group find distance variable is going to be the one that you're going to like a lot, because that specifies the distance that you will use in the Cartesian mode for jogging. So the units that we have in here, those are millimeters. So that stands for half a millimeter. And what does it mean? That means if you will change your speed to find speed and you want to jog in it, the robot will move just by this much and then stop. To show you this, let's set this value to 5. That will equals to 5 millimeters. Let's zoom in on our robot a little bit and let's try to jog in the fine. So when I hit Z+, the robot will go up and then stops. So from the point that he has started, he just moved by 5 millimeters that I define in here and then stop. We're going to put 10 millimeters in here and try to jog the robot. Let's see what happens. The robot will move for 10 millimeters and then it will stop. Guys, very, very, very useful variable. I use it a lot. I highly recommend using it and playing with it. Okay, that would be all about the jog group variables, at least for now. And the next variable that I think comes handy is called SCR group. So basically that stands for group system configuration record. So let's go over there. So we gotta scroll down all the way to S. And in here we have our SCR group. When we go inside, what would be a point of our interest, guys? So there is a very, very cool variable that you might want to use. I've used it for a few projects so far, and it's this one. So basically that variable can be set to false or true, and what it will enable or disable is those points, those variables. And why do we need them? Because you can use those to send your position data to a PLC. I think I did respond in one of the questions that you've asked about it, and I think that I described how to do it very briefly over there. But let me show you how this works. First of all, I wanted to mention that this position is going to be a position in a world coordinates. So that's going to be a position in your tool frame 0 and user frame 0. Still, you can find it useful. As well, you can find the position in here. But let's see how this works. So first of all, that doesn't work when you are jogging the robot. So if you try to jog the robot, that position is not going to update. That position, that will work only if you are trying to execute a robot movement. So let's see how that works. Let me open it. I got to open it on the right side, otherwise we're not able to execute the program. Oops, sorry, wrong variable. Let me just check the number. 666. Okay. All right, and let's run a program. So that's my old program, and let's try to run it. So let me try to run to the first point. And as you can see, as the robot is moving, the values in here are changing. Now the refresh rate is not the greatest, so if you want something very precise, I would not recommend to use it. However, that's an option of using that variable. When we set the variable to false and we're going to execute the movement, the values won't update even though our robot will be moving. So that's a cool thing. You got to enable that variable and you can take those values and send it to PLC if needed, of course, if needed. So you can check the current robot position. Might be useful for recovery, guys. I think you can figure it out a way of using it inside your systems. Okay. What else? This is something that annoys me a lot, and that's something I like to change. So that variable I'm going to show you right now is for those buttons. So basically for changing the speed override. Let me just find it. So as you know, probably those buttons works in a two-way. Like one of my very first videos, I told you that the buttons that are blue work with the shift, because when you hold them, the blue buttons act differently than while not holding. Like the arrows, right? You can skip just one, but when you hold the shift, you're going to skip more than one. And so on. And the same as you can see in here. So when we change the speed without shift, it will go by 5. But when we hold the shift, it goes, as you can see, like through predefined values. Now, I already changed something that is overwriting this variable, but when that variable is set to 0, basically, you cannot use your shift override. When that variable is set to 1, you can use it. Let me show you what I've changed, because I think that's going to be interesting, and then I show you exactly how this function works. So in order to play with the speed, we got to go to override rate variable. So let's go to override rate. And okay, and let's get into the setup. So there are a few things in here that you want to know. So basically, there is an override number. There is an override number S, and there are two variables that comes with it that contains integers. So as I showed you before, you can change the override just by pushing the button, or when you hold the shift and push it, and then as you can see the values change differently. So with those two variables you can set a predefined, let's call it jumps or iterations that the number will change. So when you go in here and hit enter, there are 10 values that you can put and use for speeding up or slowing down the robot. Now the important thing, whenever there is a 0 in here, that means that you will not use any of those and you will use a predefined speed incremental. So if we want to use all 10 in here, you want to put 10, hit enter, then go in here and predefine your speeds. So -1 goes for very fine, 0 goes for fine, 1%, and so on. So you can put even a funky number like 23, let's say. Let's do 65. Let's do 88. Let's do 90. And let's do 100. So right now, because I changed it, if I won't use shift button and I will decrease the speed, it will go by the values that are specified in here. So that's very cool thing. Then the other one is the same thing, but with shift, that the S indicates the shift button, And when you go in here and hit enter, you can predefine the values that you want to use while holding a shift button. So let's do 24 in here, let's do 45, okay, let's do 78, let's do 91 and 100. And now when you hold the shift button and you change the speed, it will go as you declared on the robot. Pretty cool? I guess so. Now I wanted to show you the other thing. Let me just make it a little bit nicer. I want to disable this guy because I don't want to use it. Because there is one more thing that I wanted to show you. So normally this will go just by 8, I think, and that will be 100, that will be 50. Okay, make sure. Yep. Okay, let's go back to the variable I talked about at the beginning so you can have a better understanding. I just forgot that I played with it before. So so right now when you hold the shift button, you'll go to 25, 50 and then 100. When we disable that, we are disabling the shift option. So whenever we won't define anything in our override, that will, I forgot to change it, guys, sorry. That won't work. So basically, normally in FANUC, that option is enabled, and whenever you're holding the shift button, we jump by a predefined number. Whenever that's enabled, you're going to use the shift button. Whenever that's disabled, you won't use the shift override. Okie dokie. What else, guys? The next variable I wanted to talk about is the general override, and that's in MCR. So we're gonna go back a little bit. We're going to go to M. And basically, we wanna find general override in here. And it's this one. So basically that variable represents this. So whenever you change this variable, this will change. So by overwriting this variable, basically you can overwrite robot speed. That means you can send or receive something from a PLC on a group output, actually on a group input, and then assign this value to this variable using the mixed logic that I mentioned in my previous video. This way, you are able to change robot speed while the robot is running without pushing the buttons. So you can change it either by pushing the buttons, or you can change it by putting it by hand. Okay. And right now, when I was telling you about the speeds, that just reminded me about one more thing with changing the speed. So you can change it with the buttons, or you can change the value in here. I forgot to mention about something else. Let me go back to override. There is something called override rate. So right now, because in our override setup, we have the regular override disabled because it's set to 0. And when you're going to do minus, as you can see, we go down by 5. And in here, with the override rate, you can set the value, let's say 15. And now whenever you hit plus or minus, you will go up by 15. So I think that's something pretty cool. So instead of, let's say in override setup, defining or predefining your own values, you can always use the override rate, and then without the shift, you will use it like this, and then with you can assign values to shift and just change it to something else. Just remember with the shift that you need to have it enabled, and then that was the thing I wanted to show you. When you hold the shift, you go by 5, 50 and 100, and that's something that very annoys me. It didn't work before because in the setup I predefined the values. As you can see, a few seconds ago I just changed it to 0, and when you change it to 0 now and you try to change the speed, it won't use the shift, it will use the override rate that we changed. With the shift enable, we will go by 100, 50 and 5. So very annoying, guys. Sometimes I will run the program, I forget about changing this variable, I want to speed up the robot just by a little bit, but I have the shift override enabled, and then boom, I will jump it to 50%. Alright, that will be all of the important variables that I wanted to share with you. There is many more, but I think for now that's something that those variables are most useful and I use them a lot. So I hope you enjoy and play with them. Thanks, guys. Alright, thank you for watching, guys. Like always, please subscribe to the channel, leave the like, leave your comments down below. What can I say? Like always, see you in the next video. Bye bye.